Now we are putting these three motives together. In putting the three motives for holding money balances together into a demand for money equation, Keynes was careful to distinguish between nominal quantities and real quantities. Money is value in terms of what it can buy. If all prices in the economy double, the same nominal quantity of money will be able to buy only half as many goods. For example, if the price level increases in an economy, it means you would be able to buy less before the price increase has occurred. So the question is, money is valued in terms of what it can buy. It means the purchasing power of money. If all prices in the economy double, the same nominal quantity of money will be able to buy only half as many goods. Keynes thus reasoned that people want to hold a certain amount of real money balances. So what do we mean by real quantity of money or real money balance? When you divide money supply or money by price level, M divided by P, this is known as real money balance. If P increases, people must hold more money to buy same amount of stuff. Keynes wrote down the following demand for money equation, known as the liquidity preference function. This is the liquidity preference function, MD divided by phi, which is known as the real money balance. We can say that the real money balance is the function of I and Y. The demand for real money balance is negatively related to the interest rate and positively related to real income. Keynes' conclusion that the demand for money is related not only to income but also to interest rate is a major departure from Fisher view of money demand, because in the Fisher quantity theory of money we are saying that income is the only determinant for the demand of money. But J. M. Keynes concluded that the demand for money is related not only to income but also to interest rates. Keynes and velocity. By deriving the liquidity preference function for velocity, we can see that Keynes' theory of the demand for money implies that velocity is not a constant, but instant fluctuates with moments in interest rates. So in the Fisher theory, we saw that velocity was constant in the short run, but J. M. Keynes says that velocity is not a constant value, but instant fluctuates with moments in interest rates. It means that if interest rate fluctuates or if interest rates change, velocity will also change. So the liquidity preference equation can be written as, if we change this expression from md divided by p to p divided by m, we are just bringing numerator to the denominator place and denominator to the numerator. So we can write as p divided by md is equal to 1 divided by f I y. Now multiplying both sides by y and replacing md with m, they must be equal in the money market. As you know that when the money market is in equilibrium, we can say that money demand is equal to money supply. If we can say that money demand is equal to money supply, so we can replace md with m. md is the money demand for money, and m is the supply of money or money supply. So we can write as v is equal to py divided by m, which is equal to y divided by f of I y, because we are multiplying y on both sides of the equation. And you know that py by m is known as velocity. It means that in the Keynes liquidity preference theory, we can write velocity as v is equal to y divided by f of I y. Now look at the relationship that how velocity is changing with the interest rate. Number one point, I increases. Suppose if interest rates increase, if up IY decrease and we increase, it means that there is a positive relationship between I and we. In other words, a rise in interest rates encourages people to hold lower real money balance for a given level of income. Therefore, the rate of turnover of money must be higher. This reasoning implies that because interest rates have substantial fluctuations, the liquidity preference theory of the demand for money indicates that velocity has substantial fluctuations as well. An interesting feature of this equation is that it explains some of the velocity moments in the previous figure, in which we noted that when the recessions occur, V falls, or its rate of growth falls. What fact regarding the cyclical behavior of interest rate might help us explain this phenomena? As we know that interest rates are pro-cyclical, it means that the interest rates rise in expansions and fall in recessions. That is known as pro-cyclical. The liquidity preference theory indicates that a rise in interest rate will cause velocity to rise. The pro-cyclical moments of interest rate should induce pro-cyclical moments in velocity. It means that velocity fluctuates with the interest rate. That is, both are pro-cyclical. If interest rate increases, velocity will increase. If interest rate decreases, velocity will decrease. Change in expectations of future I change if IY and V changes. Velocity will change as expectations about future nominal level of interest rates change, because interest rates are then expected to be higher in the future. More people will expect the prices of bonds to fall and will anticipate capital losses. The expected returns from holding bonds will decline, and the money will become more attractive relative to bonds. As a result, the demand for money will increase. Velocity will change as expectation about future normal levels of interest rates change. An unstable expectation about future moments in normal interest rate can lead to instability in velocity. This is one reason why J. M. Keynes rejected the view that velocity could be treated as a constant. J. M. Keynes' model of the demand for money has the important implication that velocity is not constant, but instead is positively related to interest rates. His theory also rejected the constancy of velocity. That is, velocity is not a constant. Because changes in people expectation about the normal level of interest rate would cause shifts in the demand for money that will cause velocity to shift as well. The Keynes liquidity preference theory caused doubts on the classical quantity theory of money that nominal income is determined primarily by moments in the quantity of money.